Okay, in the last class we are discussing about the interfacing of the memory to the 8086. So, I have discussed about example interface 8 kilobytes of the EPROM and 8 kilobytes of random access memory to 8086. So, in the last class we have discussed about the address map of this 8K EPROM and 8K RAM. We assumed that so out of this 1 megabyte. So, I want to interface this EPROM in the last 8 kilobyte of the locations. So, the ending address will be FFFFH. So, for 8K we have to subtract 1 FFF. Okay. So, FF minus 1 FFF will be E0000H. So, the starting address is E0000H. Here I want to interface the EPROM. This is total 8 kilobytes, and I want to interface RAM just above this EPROM. So, the address which is 1 less than this one will be DFFFF, and to get the starting address you have to subtract 1 FFF. So, DFFFH minus 1 FFFF. So, this will be 0000 C0000. This will be C0000 to DFFFF. Okay. Now, in order to interface this, we have to write the memory map of this particular addresses. So, what is the memory map of RAM? So, total we have 20 address lines: A19, A18, A17, A16, A15, A14, A13, A12, so on up to A0. Okay. So, in case of 8 kilobytes, 8 kilobyte of the memory, how many address lines will be present for 8 kilobyte? So, we know that 2 raised to the power of 10 is equal to 1 kilobyte, 1K. And if you want 8K, you multiply on both sides with 8, which is 2 cube. 2 cube into 2 to the power of 10 will be 2 cube is 8, 8K. So, total we have 13 address lines for 8K memory. So, A0 to A12. These are the address lines of the microprocessor has to be connected to 8 kilobytes of the memory. Memory will be having some address lines, depends upon the capacity. For 8K memory will have 13 address lines. So, I am going to connect this A0 to A12 to the corresponding address lines of the memory. Okay. So, what is the starting address? Starting address is for RAM C000H. So, what will be this bits A19 to A0? C is 12, which is 1100, and 0 is 000, and then all zeros is C000H. So, you see E000, D00 minus 1 is C00. This is C00H. Then ending address will be DFFFH. So, this will be D is 13 1101 F is 1 1 1 1 and all ones. This is the address corresponding to DFFFH. Similarly, what is memory map of EPROM? The starting address is E000H. E is nothing but 14, which is 1110, then all zeros is E000H and ending address is all ones. FFFFFH. This is the memory map. By varying this A0 to A12 from 0000 to all ones, we can choose any of the locations from 8 kilobytes of the memory. Okay. Now, what are the addresses that are left? A13 to A19 are left. Okay. So, now we have to use this A13 to A19 to select the chip selects of this particular memories. And also we know that in 8086 the memory is available in two banks, even and odd banks. Okay. So, total we have 4 memories, 2 even memories, 2 odd memories. Then how this has to be connected? So, we have here 8 kilobytes of the RAM odd, eight kilobytes of the memory read only memory even, similarly we have, this will be 4 kilobits only, because we have divided into even and odd, half of this memory will be available. Then we have 4 kilobytes of EPROM, odd, 4 kilobytes of EPROM even. So, what are the different signals for this 4K RAMs and 4K ROMs? So, we will be having how many data lines and how many address lines? So, this will have 12 address lines, because 2 raised to the power of 12 is 4K. So, this is A11 to A12 to A1. So, 1 to 12 is total 12. Similarly, here also we will be having A12 to A1. Why you have not used A0 is, A0 we will use to select the banks. For even bank, A0 is always 0. So, we will use this A0 to select the banks, to find out the chip selects of this. If I call this one as chip select 1 bar, chip select 2 bar, chip select 3 bar, chip select 4 bar. To determine these values, we will use A0 and BHE bar. A0 and BHE bar, bus high enable bar are used to obtain the chip selects. Of these memories. Okay. Then here also we will be having 12 address lines. Here also we will be having 12 address lines. A12 to A1, A12 to A1. This you have to connect to A12 to A1 of 8086. So, all these four memories address lines you have to connect together, and that has to be connected to A12 to A1 of 8086. Okay. Similarly, data, this will give 8 data lines, this will give 8 data lines. So, here this odd will give D15 to D8, even will give D7 to D0. Total we have 16 bit data. If you want 16 bit data, you have to enable both even and odd banks. If you want only 8 bit, we have to enable either of these banks. Similarly, here also we will be having 2 data buses. This will give D15 to D8, this will give D7 to D0. This you have to connect to D15 to D0 of 8086. And EPROM will be having only read bar signal. This is read bar signal. This is also having read bar signal. You connect this to read bar signal of 8086. Okay. So, while discussing about the pin diagram, we have discussed that 8086 will be having read bar signal. Whereas in case of RAM, we will be having both signals, read bar as well as write bar. You connect to the corresponding read bar and write bars of 8086. So, these are the different signals. Now, how to select the chips, so that this memory RAM will operate at the address that I have specified in the last slide, which is from C0000H to DFFFH, and EPROM will interface starting from the address E0000H to FFFFH. Okay. So, if you observe here, so in this memory map, so this A19, A18, A17, they are all A19, A18 are 1 in all the cases. Okay. So, whereas this A17 to A13 is 0, all zeros, A17 to A13 for the last address is 0, 1, 1, 1, 1. Okay. So, we can use here because we have 4 banks, okay, and we have A0 as well as VHE bar. To select this chip selects, we can take a 3 to 8 decoder. So, I am going to take a 3 to 8 decoder here. So, 3 to 8 decoder. So, if I take 74138 is the IC, 74LS138 is 3 to 8 decoder. So, this will have 3 enable signals, E1 bar, E2 bar, E3. E1 bar, E2 bar are active low signals and E3 is active high signal. Okay. And we will be having 3 inputs, A2, A1, A0. And 8 outputs, Y0 bar, Y1 bar, Y2 bar, Y3 bar, Y4 bar, Y5 bar, Y6 bar and Y7 bar. So, in order to make this E1 bar, E2 bar, E3, so you have to use this A2, A1, A0 from the memory map. So, in case of memory map, if I choose this RAM, so in case of RAM, A17 will be 0, 0 always, whereas here A17 is 1, 1. Okay. So, the only difference between this RAM memory map and EPROM memory map is A17 is 0 0 from starting to ending address of RAM, and A17 is 1 1 from starting to ending address of EPRAM. So here if you observe this A17 is 0 in case of RAM, A17 is 1 in case of EPROM. Okay. This A17 I am going to connect to A2 of this decoder, and A0 and BHE bar, as I have told, we have to use for selecting the chip select. So I will connect here A0, here BHE bar. Then what about the remaining address lines? A7 I have to use it. So the remaining are A13, A14, A15, A16, A18 and A19. Okay. A18, A19 are always ones only. Okay. So in here in case of EPROM, this A13 to A16 starting address they are 0, ending address they are ones. Okay. So I can use this A18 and A18 for generating this. Both are ones to generate 0. So you can pass through the NAND gate. And if you pass to the NOT gate, this will becomes 1. This is A18, A19. Okay. Now here how to select CS1, CS2, CS3, CS4. So this depends upon this A0 and BHE bar. So I can form a table now. So this BHE bar A2, A1, A0 of decoder. This has been connected to A0 is connected to BHE bar of microprocessor, and this A1 is connected to A0 of the microprocessor, and A2 is connected to A17 of the microprocessor. Okay. So if you have 0 0 0, you have total 8 combinations. 0 0 0. So if all are 0 0 0, Y0 will be selected. Okay. So Y0 becomes 0. Output will be Y0 will be 0. So if it is 0 0 0, what is the operation? So A0 is 0, this A0 is 0, BHE bar is 0 means it is a word operation, and because A17 is in case of RAM, A17 is 0, in case of EPROM A17 is 1. 0 means RAM, 1 means EPROM. So A17 is 0 means this represents RAM. So word from RAM. This is the operation here. Word from RAM is you have to select both the banks. Okay. Then if I take 0 0 1, what happens? BHE bar is 1, so bus high enable will be disabled. Okay. Only even bank will be selected because A0 is equal to 0, and 0 means RAM. Okay. So this will be even bank of RAM, so it will be selected. Select even bank of RAM. Fine. Then 0 1 0. Now BHE bar is 0 means bus high enable is 0, A0 is 1 means odd bank, A2 is 0, so RAM. So select odd bank from RAM only. 0 1 1, this is no operation because both A0 and BHE bar is disabled, so not at all selected. So this will not be allowed. Okay. And if I take this 4 will be for RAM. Now next 4 will be for EPROM will be 1 0 0, 1 0 1, 1 1 0, 1 1 1. These are all for EPROM. So A2 is 1 means EPROM by default because of that address map that I have discussed in the previous slide. So A0 is 0 means this one will be wired from EPROM because both BHE bar is 0 as well as A0 is 0. Okay. 0 1 means select even bank of EPROM. 1 0 means select odd bank of EPROM, and here no operation. Now how to connect CS1? So CS1, in order to select CS1. So what is CS1? The odd bank of RAM, odd bank of random access memory. Okay. So in which cases this odd bank of random access memory has to be selected? Selected means chip select should be 0. Okay. So here if 0 0 0 0 is there, so if I apply 0 0 0 0 here, then Y0 will be 0, remaining all will be 1 because this is active low signals, Y0 bar, Y1 bar, Y2 bar and so on. Okay. Now, so in order to select CS1, how to obtain the expression, Boolean expression for CS1. Okay. This is 4 kilobytes of the odd RAM bank. This is odd RAM bank. Here also this odd RAM bank has to be selected as well as here also, because if you want to select the word, both even and odd banks has to be selected. So in the first combination also we need the first RAM odd bank, and in the third combination also we need this. So in the first combination, which of the output will be selected? Y0 bar. This is Y0 bar and this is Y2 bar. So whenever either Y0 bar is 0 or Y2 bar is 0, then CS1 of the first 4K RAM odd has to be 0. Okay. So what will be the logic? You simply connect Y0 and Y2 bar through NAND gate to the chip select of this. So if either this is 0, what will be the output? Output will be, sorry, this is not NAND gate, this should be AND gate. So if Y0 bar is 0, output is 0. If only Y1 bar is 0, output is 0. If both are 0 also, output is 0. Okay. So if both are 1s, then output is 1. Okay. So in order to select this odd bank of the RAM, either Y0 bar should be 0 or Y2 bar should be 0 or both should be zeros. Okay. In any case, chip select is selected. So this is how we can derive the expression for chip select of the first odd RAM bank. Now what about CS2 bar? How to generate the signal for CS2 bar? In which cases CS2 bar has to be selected? CS2 bar is even RAM bank. So this can be either the first one or the second one. In the first it is word, so both even and odd has to be selected. In the second it is only exclusive even of RAM. Okay. So in these two cases, so what will be this output of this chip select signal? So here also you have to connect to a AND gate. The output of the AND gate you have to connect to the chip select of this even RAM. What will be the inputs now? Because the first two are Y0 bar and Y1 bar. Clear? This is about the RAM selection. Now coming for the EPROM. So in the EPROM, what about the odd? Chip select of odd bank. So chip select of odd bank will be enabled in this case as well as in this case. These two for odd. whereas these two for even. The first the 100 combination will be selected for both even as well as odd. So what will be this inputs for the AND gate? Here also you have to connect the output of AND gate to chip select of these. So what will be the input for the odd bank? Either this can be 100 or it can be 110, means 4 and 6, 4 and 6. Similarly for chip select 4, another AND gate, output you have to connect to chip select. What will be the inputs? 4 and 5, 4 and 5. This will be Y4 bar, Y5 bar. So this is about the complete interfacing of 8 kilobytes of the RAM and 8 kilobytes of the EPROM to the 8086. So basically you have to draw the memory map, and from that you have to choose the corresponding bits. I will take one more example where if you have the different sizes of the RAM and ROM. Interface 32 kilobytes of EPROM and 64 kilobytes of random access memory, starting at 00000H to 8086 microprocessor. So the memory map of 64 kilobytes of RAM is given, the starting address, whereas the memory map of EPROM is not specified. By default, as I have discussed in the earlier class also, we have to connect EPROM at the end of the memory, because whenever the microprocessor is reset, the microprocessor will goes to FF0 location. So by default, if address is not given, you have to connect the EPROM in the last locations of this total memory map. Here you have to connect EPROM. So what is the ending address is FFFFH. This total 32 kilobytes. So what will be the starting address? As I have discussed in the earlier class, 1K means it is 3FF. Okay. 2K means total you have to add 7FF. 4K means FFF. 8K means 1FFF. 16K means 3FFF. 32K means 7FFFF. And 64K means FFFF. These are the values that you have to add to the starting address to get the ending address, correspond to 1K, 2K, 4K, 8K, 16K, 32K and 64K. Okay. So if the ending address is FFFF, this is 32 kilobytes. To get the starting address, you have to subtract 7FFF. Okay. So what will be this 7FFF if you subtract from FFFF? If you subtract 7FFFH, zero 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 8 F8000H. And RAM, it's given that you have to connect at the starting of the this total 1 megabyte of the memory. Zero 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 H, And what is the capacity 64 means ending address will be 0 FF FFH. This is the RAM of capacity 64 kilobytes. Now in order to connect this, again we have to draw the memory map. So what is the memory map of RAM? Starting address is 0000, A19, A18, A17, A16, A15, A14, so on up to A0. So starting address all zeros is 00000H. Ending address is 0 FFFH. 0 is 4 zeros, FF means all ones, is FF FF FH. And in this this particular 64 kilobits of the memory will be having how many address lines? 16 address lines. This is the memory map of. So A0 to A15 you have to connect to A0 to A15 of 8086. Now only these address lines that are available to find the chip select are A16 to A19. Similarly, what is the memory map of EEPROM? A19, A18, A17, A16, A15, A14, so on up to A0. Starting address is F8000H. F is 1111, 8 is 100, all remaining all are zeros. This is F8000H. And ending address is all ones, 1111, 11, all are ones. This is FF FF FH. Now here how many address lines will be there for 32 kilobytes? Only 15 address lines. So A0 to A14. Okay. Now in order to find out the chip selects of this one, okay, so how to use 4 memories total, 2 even and 2 odd memories, similar to the previous example. Out of 64 kilobytes of the RAM, 32 kilobytes of the RAM we have to use as odd bank, and 32 kilobytes of the RAM we have to use as even bank. Similarly, out of 32 kilobytes of EEPROM, you have to use 16 kilobytes of EEPROM as odd bank and 16 kilobytes of the EEPROM for even bank. For even bank. So what are the corresponding address lines? We have to connect to the corresponding address lines of the 8086. 32 kilobyte will be having 15 address lines, A15 to A1. This is also A15 to A1. This you have to connect to the A15 to A1 of 8086. Here also we are not using A0 because A0 we are going to use to find out the chip select of these ICs. Similarly, here this will be having only 14 address lines. So you have to connect from A14 to A1. This you have to connect to corresponding microprocessor. So all the 4 buses you are going to connect to the common bus of 8086. Now the question is, so how does this 4 devices will be different? at any time only one of this memory will be selected. So, the data transfer will be taken place with that particular memory. Okay. Even this common bus of 808C is connected to all the 4 memories. At any time only one of the memory is selected, so that the data transfer takes place between the selected memory. Okay. Here you can use the decoder, or I will use the other concept directly by using the gates. Okay. Because here RAM and ROM are having different memory sizes. So, RAM size is 64 kilobytes, EPROM size is 32 kilobyte. Okay. So, here you can observe that. So, in case of random access memory, this A16 to A19 will be always zeros. Okay. So, I will select a signal using NAND gate whose output will be 0 if A16 to A19 is 0. So, you can connect like this NOT gate. You give the inputs as A16, A17, A18, A19, and you call this output as some P. So, P is equal to 0 if A16 is equal to A17 is equal to A18 is equal to A19 is equal to 0. Otherwise, P is equal to 1. If any one of this A16 to A19 is 1, output will be 1. Okay, because if any one of this one is, say, A16 is equal to 1, for example, this will be 0. If one input is 0 for the NAND gate, output will be 1 regardless of the other inputs. Okay. So, here this P is equal to 0 only if A16 to A19 are zeros. This A16 to A19 will be 0 for these combinations of the memory location 00000H to FFFFH. Sorry, this is 0 FFFFH. Okay. Similarly, I am going to derive another signal using this P. So, this P I will take as one input. So, what are the additional signals for the EPROM? EPROM, the signals that we are going to connect to the microprocessor are A0 to A14, okay. A15 to A19 are available. So, here out of this I have connected A16 to A19, so which will generate 0 here. Now, I will connect this A19 as another input for this. If I call this as C, NAND gate. Okay. So, when the C is equal to 0, if A15 to A19, if all are ones, what happens? If any one of this A15 to A19 is 0, otherwise I will generate this C separately. Instead of generating from P, I will generate separately in a similar manner. So, I will take a NAND gate, but I will not take the inverters now. I will call this one as C. The inputs are A15 to A19. A15, A16, A17, A18, A19. So, C is equal to 0 if A15 is equal to A16 is equal to A17 is equal to A18 is equal to A19 is equal to 1. If all are ones, then only output is 0. If any one of this A15 to A19 is 0, output is 1. So, I am using two signals P and C. Using this P and C, I will select the memory banks. P is 0 for RAM locations, all the RAM locations, and C is 0 for EPROM locations. Okay. Now how to select this chip selects of these 4 ICs? Chip select 1 bar, chip select 2 bar, chip select 3 bar, chip select 4 bar. So now to select this EPROM, so how to select this chip select 1 bar? So for chip select 1 bar, it should be odd of RAM. Okay. So P and BHE bar and A naught will decide about this CS1. Okay. So if P is 0, and A0 is, this can be 0 0. So what should be this CS1 bar? CS1 bar. CS1 bar has to be selected in case of wide selection from the RAM or only odd bank. Okay. So this P is equal to 0 by default. This is for RAM. So no need to consider, you can write here itself P is equal to 0. Now BHE 0, A0 0 means chip select bar has to be selected because this is wide from the RAM. Okay. And when P is equal to 0, this is 0 1, what should be CS1 bar? This is BHE bar, high enable is 0 means high bank we are not going to select, only low bank. So this high enable is 0 means high bank which is odd bank has to be selected, this will be 0 because BHE bar is 0, high bank means it is a odd bank has to be selected, so 0 0 1 0. So this is even bank, so this will not be selected. This is 0 1 1, no bank will be selected, so this will be 1. So only in these two cases only CS bar should be equal to 0. So what is the Boolean expression for CS1 bar? CS1 bar is equal to P bar BHE double bar A0 bar plus P bar BHE double bar plus A0. Okay. So here this A0 is 1 in one case, another 0 in another case. If I take this P bar and BHE double bar, of course BHE double bar becomes BHE. If I take this as a common, you will get A0 plus A0 bar. This is equal to simply P bar BHE bar. So what will be chip select of this one? P and BHE signals you have to connect to this. So when both are zeros only, output should be 0. So what should be the gate? AND gate. This is P and BHE bar. You see here. So in these two cases, P is 0, BHE bar is 0, so output is 0, this chip will be selected. So in these two cases, so this will not be selected because BHE bar is 1, P is 0, so output will be 0. So it will be selected. So you have to exclude this. So for that you have to take NAND gate, right? You have to invert here otherwise. Okay. Now I think it's correct. So if both are zeros, then here these two will be 1. So output will be 1. So it will not be selected. This should be NAND gate. So this is both are zeros means 0 0. This will be 1 1 1. It will be 0. If any one of the input is 0, then what happens here? This will be 1 0. If one of the input is 0, output will be equal to 1. It will not be selected. So this will work out. Okay. So the circuitry will be, so for P is equal to 0, BHE bar 0, for P is equal to 0, BHE bar 0, this will be always 0. 0 if both BHE bar and P bar is equal to 0. Okay. Similarly, you can derive the chip select of even bank. So, what will be chip select of even bank? For that RAM only, so P is equal to 0, P should be 0, BHE bar, A0 bar, CS2 bar. So, it should be 0, 0, 0, 0, 1, 1, 0, 1, 1. So, bus high enable is 0 means we should not select this chip because this is only high bank. Okay. So, this is both are 0, so you have to select. Here you do not select, here you have to select, here not select. This is even bank, so Y0 is equal to 0, this you have to select, this you have to not select. Okay. So, here BHE bar will get cancelled, so you will get same in terms of P. You can verify this, that this output will be P and A naught. Similarly, here you can get NAND gate, here we will get NAND gate outputs. The inputs of this one will be C, BHE bar, and here this will be C A naught. In a similar manner you can check for this. So, like if you want CS3 bar, so the inputs will be C, then BHE bar, A0. So, C should be 0 for EPROM. If this is 0 0, what means both the banks has to be selected, chip select should be 0, so that it will be selected. 0 1 means is high bank, which is odd, this has to be selected. 1 0 means this is only even bank, so odd bank should not be selected. 1 1 means no bank will be selected. So, if I take the Boolean expression here, A0 varies from 0 to 1 here, which will get cancelled. So, only C and BHE bar will be there, you have to connect through NAND gate. Similarly, for CS4 bar, we can write C, BHE bar, A0, CS4 bar, this should be 0 for EPROM. 0 0 means both the banks, so this has to be selected. 0 1 means this is high bank only, odd bank, so even bank will not be selected, means 1. 1 0 means only lower bank, which is even bank, so this has to be selected. 1 1 means no bank is selected. Okay. So, you can if you write the Boolean expression, you will get NAND operation of C and A naught. This is about the complete memory map of this particular problem. Okay. So, this is how we can interface the memory to the microprocessor. Okay. Now, we will discuss the I/O mapping with the microprocessor. So, in order to map most of the I/Os, so we will require some extra peripheral pins called, there are some like 8255 is programmable peripheral interface. This is required to connect most of the input output devices, and there are some special ICs to connect keyboard and to connect this printer and all. We have DMA, we have different ICs. So, but most of the useful IC for connecting the IOs is 8255. This 8255 I will discuss in the next class. Thank you.